Coming up, we have Drishti Jain with us to explore the intersection of Kubernetes and machine learning and discuss best practices for managing and scaling AI workloads, highlight challenges and solutions, and many more. Welcome, Drishti. Let's have a huge round of applause for her. She's very excited for the talk.
Hi everyone, I'm Drishti Jain, and I'm really excited to be speaking on something that most of us, especially in the Kubernetes world, love to explore and have that more integrated in a much scalable way in our applications. I'll be speaking all about Kubernetes for machine learning and moreover also sharing some important complex topics. I'll try and make it very easy for you to understand so that you are able to also build very, very highly scalable AI workloads. So, to kick off my presentation, let me tell you a little bit about myself. So, I'm Drishti Jain, and today for the conference I came all the way from Pune, and I'm really excited to be at KCD Mumbai. I'm also a software developer as a full-time profession, being a computer engineer. I'm also a tech geek, a social entrepreneur. So, I have my own non-profit organization, and we work across 11 cities in India, including Mumbai, and we have a strong 400 plus volunteers team, and that is the place wherein I like to create a change in the world, and all the volunteers as well, all of us aim and making the world a more better place, especially for the underserved communities across the country. And I'm an international tech speaker, so I speak across the globe on various technologies in various technical conferences. I'm somebody who loves to share knowledge, who loves to give back to the community, because community is the place that helps us grow. So in turn, I like to share my knowledge, anything and everything that I learn. And I have my own initiative called Skill Up with Drishti. If you scan the QR code, you will go land on my website. And if you are even looking to connect with me one-on-one, I have my calendar link there. So you can feel free to book a slot and let's get in touch about anything related to community, career growth. It's all up there. And yes, don't forget to follow me along on Twitter. That is wherein I share all of my conferences or anything that I'm building on. It's all public and it's right there. So let's look at Kubernetes. Especially in this room and the developer community we have today, Kubernetes is something that brings that big smile on our faces. What does it make us do? It makes us all very, very happy. We just love it. And we are all here to explore what is the additional thing that we can do with Kubernetes. The reason why we as developers love Kubernetes is because it makes production workloads very easy and also gives us the tools right on our fingertips so that we are able to scale up our applications, make our applications such that they are production ready, and take our application from a POC stage, a proof of concept stage, to something that can also be sold and be an enterprise grade application and can actually help millions of customers, millions of people across the world. In general, if we look at what the Kubernetes architecture is, we will see that what makes Kubernetes different from others is our ability to have different clusters, different containers across different pods, and that is how, especially when we are working with machine learning and when we are aiming to scale AI workloads, we are able to achieve it. Also with Docker, Kubernetes, and across the whole ecosystem, it becomes very, very easy for us to scale our applications across. With respect to machine learning, Kubernetes has a very important aspect to it of Kubeflow. So Kubeflow is what you should look at whenever you're thinking about integrating machine learning with Kubernetes. This is the heart of everything, and it is very, very simple as well. We'll be looking at a ton of code examples, but we'll take it slowly across my presentation. And Kubeflow is something which is very easy. If you spend enough time, there are a lot of tutorials, and it has a good documentation, of course, and there are small tutorials as well, which will help you transition into the machine learning space with Kubernetes. Now for Kubeflow, Kubeflow is the ML toolkit for Kubernetes, as simple as that. Whenever you are developing into Kubernetes and you think about machine learning, the first thing that should come to your mind is Kubeflow. And it builds on Kubernetes as a system for deploying, scaling, as well as managing complex systems. And all of this is very easy, and Kubernetes, since Kubeflow is built on top of Kubernetes, it manages all of the internals so that we are able to use our logic and actually solve the problem that we are creating for. I'm somebody who truly believes that we as developers have the gift and we have mastered the art of magic. And that magic is our ability to code and solve problems. As a developer, our main aim should be to solve problems. And the skill that we have acquired is the technical training we have in order to put that into code and have our code actually solve the problem. So anytime you're thinking about Kubeflow or you're thinking about any application, your reason of using a particular technology should not be the first motive. Your motive should be to solve a problem, and what is the best tool in order to solve that problem. And if you're already integrated, if you have an application that is already integrated well and uses Kubernetes, then Kubeflow is the obvious choice for you. Let's look at the overall machine learning workflow of any enterprise-grade application that we have. So there are two phases. One is the experimental phase, and the other is the production phase. So in the whole, you can think of experimental phase to be the phase wherein we are still trying to see if a particular thought, a particular idea is a viable product or not. We see around us the rise of LLMs, the rise of VR. All of us must have seen the latest announcements as well. So the world is moving very fast in technology. And in order to see if something is viable, is of a commercial grade use, has that enterprise level completion to it, that is wherein our experimental phase comes in. We would try different things, we would see the application of different things, and that is how we would understand if we are ready to take it from the experimental phase to the production phase. To summarize all of the steps in the workflow, there are 4 major steps. The first one is whenever you have a lot of data, you need to aggregate it, clean the data, analyze the data, and what is the data trying to say to you. And then based on what the data is trying to say to you, you would try and find a correlation between the data points. That is wherein you need an algorithm which would be able to predict, or an algorithm which will be able to inference something out of your data. That is wherein you choose a particular algorithm for your data set that you have. And then you would experiment with the data and model training. So you would tune your parameters, you would see, does one feature have more power as compared to other features or not? Is there a dominant feature? Is a combination of features more dominant in our data set or not? And all of that comes into place in our third stage. And the last stage of the iterative process is to add the hyperparameters as well. So hyperparameters give you a model which is very well trained and also has the capability of predicting and incorporating any on-the-go changes. So the best example to understand the need of hyperparameters in our ML modeling is, consider the case till say 2019, and we can take the case of how people worked. Let's take our community, the tech community. So till 2019, majority people worked in offices, but something changed in 2020 which caused everybody to work remotely. So that is a huge shift. Imagine an ML model which, for example, a chair-making company had in order to predict their sales, and their whole manufacturing facility, their sales team, and every related office in their company was dependent on that model in order to be ready for the future demand that is going to come. But that 2020 of COVID-19 completely shifted their model. So the model should have a feature wherein something which has a high weight, if introduced in the model, should be able to modify the model such that the predictions change accordingly. So imagine a case like this, models which are not able to do this. We have also seen shortage of, say, chips. We have also seen an overload of material which is not being used because of COVID, and material that needs to be modified. So there's also a shift in the business logic. Anything we do, especially in the commercial space, has to have a monetary incentive to it. Only then do big organizations work. So as developers also, it is important to understand the big picture and where your model will actually create that impact, will create money in the whole ecosystem. So that is wherein hyperparameters are very important. Let's look at the Kubeflow integration with the MNIST dataset. So this dataset is a dataset of handwritten digits. So a publicly available dataset, which is all your handwritten digits by different people. And that integration with Kubeflow with TensorFlow capabilities comes into our previous diagrams like this, wherein all of our data has to be modeled. We need to understand if, for example, 8, 1, 2, 3, all our digits, when written in a particular way, should be easily identifiable. And this keeps on happening iteratively. Now, this is wherein we need a way to integrate this with Kubernetes. That is wherein we have TensorFlow TF jobs that come into place. Now, TF jobs is what gives us the ability to introduce machine learning back into our ecosystem. So what is a TF job? A TF job is a custom resource in Kubernetes that allows you to run TensorFlow training jobs. So TensorFlow allows you with a lot of inbuilt capabilities, and TensorFlow is what enables you to also have a lot of machine learning capabilities at your fingertips. It is, of course, very important to understand what a particular algorithm is doing internally. That will help you in the longer run of tuning your hyperparameters. But also, it is not always necessary to write the whole boilerplate code again. That is wherein TensorFlow comes handy, and TF jobs are a Kubernetes custom resource which helps us achieve this. And it is a resource with a YAML representation. This makes it very, very easy for us to understand, modify, and also scale. And TF jobs help manage TensorFlow training jobs. So what this helps us do is, whenever we are trying to build a scalable application using machine learning, so that model also has to be scalable. It should be able to cater to different geographies that the model would be used in. Say, you are a chair manufacturing company or a jacket. Let's take the example of a jacket manufacturing company. If you're building for a place which is more tropical, places which are nearer to the equator, the demand would be completely different as compared to the places which are a lot colder. You need to tackle heat here, so your cloth needs to be more breathable as compared to you need to keep the person away from cold in a snowy place. So the material shifts. So your model should be able to adapt and predict the needs. So that is wherein TF jobs come a lot handy. Now, all of this seems very complex, but it is very easy for us to implement. Let's look at how do you build a custom resource. Before that, you would want to check if your TensorFlow custom resource is installed or not. So you would do a simple kubectl to get the custom resource, and then you would see if your training operator is running or not. That is very easy to do it with getpods-n Kubeflow. Now, in order to start training your TF resource, here I've taken the example, something that you can also follow along, or if you're watching this later on, you can try it parallelly and try it yourself. This is a public example that is out there. So you can just play around with this so that you get an understanding of how the complete workflow looks like. And then you can also use this as a sample code wherein you can insert your particular application to understand how it works. And then you would want to monitor. So an important part about TF jobs, or whenever we are working with Kubeflow, is monitor it as well as get the events that are associated with our TF jobs. TF jobs are the TensorFlow jobs. So you would get your events using describe, and you would monitor your Kubeflow TF jobs using get TF job and the job name. So events as well as monitoring is very important. But more than this, what is something that all of us kind of have a love-hate relationship with? It is debugging, right? So you would want to have some sort of logs, some sort of way such that you're able to debug it very well. Whether we like it or not, but debugging is what helps us also optimize our underlying architecture, our underlying algorithm a lot more. And that is achieved by generating the logs for our TF job. So when we generate logs, we would generate logs for a particular pod in order to understand what is happening in that pod. And that is wherein we'll be able to better analyze, better understand if our TensorFlow job is actually doing what we had built it for. So logging is also very important. Now we have seen everything, right from creating a pod, creating a TensorFlow job, monitoring the pod, looking at the events that are coming out of it, and also looking at the logs in order to identify any issues or also to improve the algorithm or improve the performance of our pods as well. The overall picture looks something like this for our machine learning end-to-end workflow. So if you see in the middle right here, you have Kubeflow, which is what helps integrate both your parts. So whenever you're building machine learning models, so there are two distinctive teams or groups you can consider who have separated responsibilities. But they also need a way in order to communicate and be able to integrate both their workflows together. So you would have a data scientist team and your app developer. Data scientist team mainly becomes more of the research part. Just like in a few slides earlier, we saw two parts to it, experimental and the production level ML workflows. So the experimental part is more on the research side. So you would be working with your models, trying to make an optimal model, trying to create better hyperparameters, trying to create a model which is also very adaptable based on any external things that can happen. And the other team is the app developer. App developer is the one who actually takes that idea, that research, to something that can be used by millions of users worldwide. Take the example of any big new shift in technology that we see. Even with VRs, what we knew about VR, say, a year ago or even 6 months ago to now, what we expect to be coming out, whether it is expensive or not expensive, and what is the technology that is being used there. All of this is being made at a level such that there's an end user who will be able to consume the complex model that has been created by that research team. So this integration is what helps a company reach greater heights. And that is wherein Kubeflow helps you do that. It is easy for somebody from the research or the data scientist team to integrate it well with the application as well. Now this is all about Kubernetes with machine learning. But what is it that separates our workflows as compared to anybody else? So my main focus is also about how do you scale your AI workflows. So let's look at how do we make this more and more scalable. Because making it more scalable, more resilient, and more reliable is when you'll have your users hooked up to your platform. They would want to use more and more of your services only if they know that even if there are 10 friends working together, using the service together, you will get a reliable result back. Or it will be able to serve everybody. You would not have to wait in the queue behind one friend and 9 people are in the queue. It has to be very, very scalable. So an important concept that comes with it is affinity and anti-affinity. This is a concept which makes all of our code to be, we want to manage our pods and our nodes such that we are able to delegate tasks to a particular set of nodes out of the pool of nodes. Also, we want to make an optimized use of any of the nodes that we have. We don't want to waste any resources, yet we want our nodes to be scalable. If there are double the number of incoming requests, it is not always the right way to just horizontally scale. Sometimes you also need to vertically scale. So how do you find that, or how do you tune that right in your code? That is what we'll see. So with affinity and anti-affinity, you expand the types of constraints you can define on pods. So one way is that you have a label, and that label is associated with the number of pods. But as and when your application grows, as and when it becomes more and more scalable, just having a group of pods in your label is not sufficient. You also would have additional constraints that will come into it. That is wherein the concept of affinity and anti-affinity are very, very crucial. So in simple terms, it is the ability to constrain a pod using labels that the other pods are already running on the node. So I know this sounds a little complex, but if you just think about it, It is about you have a label, you have a number of pods, a number of nodes in it, and you want to have some additional constraint such that if these two constraints are satisfied, then this set of nodes is used, not this set. That way you're prioritizing some sort of an operation on some particular nodes. It is possible that some nodes have more computing power and you want to use it for more computing intensive kind of operations. But that node, since it has been there, say, since a year in your organization, it already has a label associated to it. So how do you manage that? Just having a separate label is not very scalable. Say you move to a different team or you have a new person onboarded to your team. It will become very difficult for that new person, even with good documentation, to understand what exactly is the inventory structure, what exactly is the node inventory or the pod inventory that he or she has to work with. So that is wherein affinity and anti-affinity become your friends. So there are two types of it. One is node affinity and the other is interpod affinity and anti-affinity. Let's first look at interpod affinity and anti-affinity. So interpod affinity and anti-affinity allows you to constrain pods against labels on other pods. Similar to what I explained about having constraints on a set of pods against a bigger sized label which is covering other pods as well. Whereas when we look at node affinity, using functions like node selector is how you achieve node affinity. There are pods, there are nodes. So there has to be a way to segregate the way we manage it. So with interpod affinity and anti-affinity, we are working on that pod. But with nodes, using node selector, we are able to achieve the concept of node affinity. And this is a simple field which can be used right in your files and by defining it. Now let's look at some code to understand node affinity. So every node must have, if we look at this configuration, to understand what node affinity is. So in this case, my scenario is wherein I want to have a label which always has the key of topology.kubernetes.io/zone. So you see the key to be here. So this is wherein I'm defining what is the key that I always want in my node affinity. And what do I also want with that? If you see, that is the value. So if it is Antarctica East 1 or West 1. So this is what helps me define what my node affinity is. It is as simple as this. The concept is very, very trivial, very important, especially when you're looking at scaling. But Kubernetes makes it very easy for us to implement it directly. So using the key and the values. Also, if I want to have, say, I have 100 nodes, there can be multiple constraints on it. Each of these are constraints. Preferably, I also want a node, say it was recently added. So for that node, my preference, if you see here, my weight is 1. This is based on the logic that you want. You can have a higher weight as well. So I have the weight to be 1, and my preference is that the key should be, I can have another node label key. So it can be anything. Say you have some latest new nodes to be added, and for example, you had that label to say 2023 June new nodes with some particular configuration. So that is the additional label. You would prefer that your node when it is picked have that as well. So that is a preference. It is not a hard constraint. It is a soft constraint. So with this, you'll also understand that there are hard constraints and soft constraints, something that if it is not there is also okay, but if it is there, it's a preference if that is available such that that is picked up. And what you can also do is there are different operators. So if you see, I talked about the keys and the values. Now this key in these, in Antarctica East and Antarctica West, so my operator of in is important. Now, you can use multiple operators. It can also be not in. Say you want to exclude 2 regions with different rules based on geographic location. Say EU has to have some different sort of nodes. There is the specific restriction to have the data in particular nodes located physically there, or the new EU regulations coming in on data saving. So how would you incorporate it without actually, breaking anything else? You would use operators, have a not in your node selection terms, and you will match your operation with not in and your cluster. Say any say EU region 1, that may be your region, that you don't want any node from that region to be picked up because your application logic is such that the EU region application is using the one in the EU region. So this is all possible with node affinity. Now, before we look into an example with interpod affinity and anti-affinity, interpod affinity and anti-affinity allows you to constrain which nodes your pods can be scheduled based on the labels of the pods that are already running instead of the node labels. So what this helps you achieve is, if you have some legacy code, that legacy code already has node labels, but you are, over the years, you have moved away from those labels, but nobody wants to touch those labels. Is there anybody who would actually go ahead and modify any node label? No, right? We don't want anything to break that we as a developer are not aware of. There could be hundreds of developers working, and some application somewhere is linking back to this node label, which we think is obsolete, but actually might create a major production downtime. So we don't want to do that. So instead of focusing on node labels to retrieve our nodes, we would work and schedule interpod affinity and anti-affinity. How this looks like in case of our code is like this. So if you see there's a pod affinity, your specification that is there. Right here, if you see, it is affinity and pod affinity, and then you would have your expressions of different values, and similar to what we looked at in node affinity and anti-affinity. Similarly, you would have pod affinity or anti-affinity. So these are the two important points to remember: affinity.pod affinity and affinity.pod anti-affinity. Here, I've taken the example of pod affinity. You can see it right in the third one of spec, that this is how I'm defining the pod affinity. It might be possible that you want some anti-affinity rule to be there. You would define pod anti-affinity. Now, what all of this helps us achieve is to have a more controlled way of using our nodes. And the more better optimized your node management is, it will help your application scale faster. And once you have a much more scalable application without more resources, you are saving the company money, and you are also saving the developer a lot of time in managing those nodes. So having scalable applications while not increasing the developer support hours, as well as saving money, it's a win-win situation for everybody, right from the stakeholders of that application to the developers. You, as a developer as well, especially for the ones who are developers in my audience, you don't want to just do the same repeated work just because you've scaled your application. So this is what will help you become more optimized as a developer. And having this in your code makes your code by default to be more optimized. That way you are able to now scale your application while keeping your workload to be the same. And this has an added advantage. When you use node affinities or pod affinities or anti-affinities, in any of these scenarios, what you're also doing is, in case of some issue that comes in your code, you have to work on less nodes. Or if some node has some configuration issue causing a downtime. So that way, it is easy for you to also fix it and get your services up running. So that way, you are also making it to be more easy to maintain. So maintainability aspect comes as an advantage to the other things with pod affinity and node affinity. Now, these are the two references. I would encourage all of you to go to Kubeflow as well as the docs of Kubernetes to understand affinity as well as anti-affinity more better, and actually go ahead and try it in your current code. The best way to try out affinity, anti-affinity, and see the impact you can have in your application is to take your existing code and make these changes in your current code. That way you will have a metric to measure what is happening first and then what is happening after you have implemented affinity, anti-affinity. So one way is that you just know about machine learning, you implement it. But what makes you different than just going through a tutorial? How do you actually implement it in an enterprise grade application? That is wherein affinity, anti-affinity come into place. And just like we talked about the MNIST dataset, that is the easiest dataset to start off with. You can start that, and using the code samples I showed, you can directly go ahead, run your model. And actually, you can also make it a lot more scalable using the concept of affinity and anti-affinity. This is what will help you grow as a developer and make your model to be more scalable and be able to reach much more wider audience. So with that, thank you very much. And yeah, these are all my socials. Before I end, I know all of us are having an amazing time after the conference, and especially at KCD Mumbai, we are having a lot of fun. So at the count of 3, I would like all of you to say KCD Mumbai and then Kubernetes together. 1, 2, 3. KCD Mumbai. Kubernetes. Yeah, thank you. I hope all of you make AI models as well as make them much more scalable. Thank you. And yes, I'm going to be around in the conference. So I know the conference is running a little late, so you can catch me for questions anywhere you find me.